In this last section of Chapter 8, we're going to conclude our talks on radicals. We're going to look at how do we solve radical equations. Originally I had inequalities planned too, but I'm going to go ahead and just kind of take off inequalities, and we're just going to look at how do we solve radical type equations. To begin, let's look at some fairly straightforward radical equations. First one involves a square root, second one involves a cube root. The first thing you want to do in any of these types of problems is get the square root or the cube root, get the radical part all by itself. Okay, so if there are any other numbers, we want to deal with those by moving them to the opposite side of the equal sign. Okay, so we take that 5 and subtract it across, giving us 11. Okay, now comes the time when we need to get rid of the radical symbol. And we do the inverse operation. Since this is a square root, the inverse of a square root is a square, is a second power. And whatever we do to one side, we do to the opposite side as well. Okay, so the square and the square root cancel, leaving us x plus 1 equals 121. We finish by solving for the x, subtract the 1 from both sides, so that we get x equals 120. Okay, on the other problem we do the same thing. We begin by getting the radical all by itself. We want cube root 5x minus 7 equals. Okay, so we get rid of that 7, and the question is, how do we get rid of the 7? Well, we divide by it. 84 divided by 7 is 12. Okay, cube root is all by itself, so now we need to eliminate the cube root, and we do its inverse. The inverse of the cube root is a third power. We do to both sides, cancels out the radical and the power, giving us 5x minus 7 equals 12 cubed. 12 cubed is 1,728. From here we'll add 7 to both sides. That gives us 5x equals 1,735. We divide both sides by 5. That comes out to be x equals 347. In this next type of example, we've got square roots on both sides of the equal sign. And I've got a number here that's not underneath the square root. Well, the problem with that number is this radical is all by itself, this one isn't. If I want to get this radical by itself, then the 3 goes over here. Well, at that stage, this radical is not by itself. So I cannot get both radicals by themselves like I did in the last problem. So since I can't do that, it's impossible to do that, I'm going to go ahead and just square both sides. When I square the left, the radical comes off of there, and I have just 7x plus 2. Now this is important on this side. I am squaring this entire side. I'm not just squaring the radical. Okay, so let me use parentheses to show that. Squaring the whole thing. That means I have to square the 3. Then I also can square the radical, and when I square the radical cancels out the square. So I have 9 times 3x minus 2. It's important to get that 3 in front squared to the 9. Okay, now it's just kind of standard equation. We've seen this type many times. Distribute the 9. Now we can start moving terms. I'm going to move the 7x over here. I'm going to move that minus 18 to this side. So that's going to give me 20 equals 20x. Divided by 20, x is 1. Okay. Same sort of problem on the next slide. The only difference is it's cube roots, not square roots. So I do a third power to this side, cancels it out. Give me x plus 6 I do a third power to this side. The third power impacts the 2 and makes it 2 cubed or 8. Third power cancels the third root, so x minus 1. So x plus 6 equals 8x minus 8. I am going to, because I like to keep the x's positive, I'm going to move this term here. I'm going to move this one over here. So I've got 14 equals 7x, divide by 7, x equals 2. The problem that follows on this side is probably going to amount to being the most challenging one of the bunch in this particular section. Not challenging to get the radical by itself. The radical's already by itself. So I square the side, cancels that out. Gives me negative 3x plus 33. Here's where the challenge is. I have to square this side. When I square this side, I have to FOIL the binomial. Okay, this means 5 minus x times 5 minus x, and I run through these FOIL steps. We get 25 minus 5x minus 5x plus x squared. Okay, I am going to set everything equal to 0. I'm going to add 3x. I'm going to minus 33. So that means we have 0 equals, I'm going to move the x squared first, minus 7x minus, not 12, minus 8. Okay, can we factor this? I'm going to go with minus 8 plus 1. We get x equals 8, x equals negative 1. Now go back and look at the title of this slide. It says an equation with an extraneous solution. We've seen that before when we solved rational equations. There may be an extra solution here. It happens often. You get extra solutions when you result in x squared equations. So I need to take these two answers and I need to substitute them in. Let's check negative 1 first. That would make negative 3 times negative 1 is 3 plus 33. 5 minus negative 1, so that's square root of 36 equals 6, so 6 equals 6, and yes, that answer is good. If I check this answer, let's see, the square root of negative 3 times 8 is negative 24 plus 33 equals 5 minus 8. So that becomes the square root of 9 equals negative 3, and that's 3 equals negative 3. That is not true. That answer gets thrown away. Again, every time I solve a problem like this, and I result in an x squared, a quadratic equation, that's going to give me two answers. I'm always going to check, because oftentimes only one of them will work. Alright, last slide of this section. What about equations that have rational exponents? Well, we know that rational exponents are just radicals. So we can solve these just like the last ones. A 1/3 power is really a cube root. If I raise this to the third power, that's what I would do if it was a cube root, it cancels that out. I'm going to raise this side to the third power also. We have 5x plus 7 equals 27, and now it's just a standard two-step equation to solve. Minus 7 from both sides. We get 5x equals 20, divide by 5, and we get x equals 4. Okay, the last problem here, it's a 1/2 power. A 1/2 power is a square root, so we raise both sides to the second power. So this makes 4x squared equals 4x plus 8. I I could divide everything by 4 and it's the same as x squared equals x plus 2. Because it's quadratic, I'm going to make equal to 0. So I'm going to bring the x over as a minus x, the 2 over as a minus 2, and then we can factor this. So we have x minus 2, x plus 1 equals 0, and we get x equals 2 and x equals negative 1. Okay, what did we say on the very last slide? Every time I make a quadratic equation, I'm going to check and make sure that these answers are good. Okay, the original equation was this. See if we can squeeze this in here. The original equation was 2x equals square root of 4x plus 8. Well, look what happens when we plug in the negative 1. The negative 1 substitute in for x gives negative 2 equals the square root of 4x plus 8. I didn't even plug it in here because I don't have to. The square root of anything is never negative. That's out. Okay, so let's just check the 2 then. That would make 4 equals square root of 8 plus 8, which is 4 equals square root of 16. 4 equals 4. Absolutely, that works.